Welcome to Kalima Maths channel. In this video, we discuss 7th class NCERT Chapter 1 Large Numbers Around Us. In that 1.2, that is Land of Tens. First question, the thoughtful thousands only has a plus 1000 button. You can observe here there is a calculator in that it has only plus 1000 button. How many times should it be pressed to show? First one is 3000. So to show 3000, it we need to press 3 times because 3 into 1000 is equal to 3000. So we have to press this button 3 times. So B bit is 10,000. So if you press 1000 button 10 times, we get 10,000. So answer is 10 times. Next C bit 53,000. So here answer is 53 times. Because 53 into 1000 is equal to 53,000. Next, coming to D bit, here 90,000 is given. So the answer is 90 times. Because 90 into 1000 equal to 90,000. Next, to show 1 lakh, how many times we have to press this plus 1000 button? So it is 100 times. Because 100 into 1000 equal to 1 lakh. Next, coming to F, here 153 times is given. If you press 153 times this 1000 button, so 153 into 1000, the answer is 153,000. In other words, 1,53,000. So this number will be displayed by the calculator. Next, coming to G bit, how many thousands are required to make 1 lakh? So how many thousands are required to make 1 lakh? So already here E bit is mentioned. So to show 1 lakh, we have to multiply 100 with 1000. So answer is here 100. 100 thousands are required to make 1 lakh. Now coming to second bit. Here this question is based upon the tedious tens. So you can observe another calculator, second calculator. Here only plus 10 button is mentioned. So the tedious tens only has a plus 10 button. How many times should it be pressed to show? So here to show 500 here, how many times we need to press this plus 10 button? So here 10 into 50 times. 10 into 0 0, next 10 5 is 50. So that means 500 times we need to press this plus 10 button to show that 500 in the display. So answer is 500 times. In the same way to show 780. So now we have to multiply 10 with 78 or 78 with 10. So then we get 780. So answer is here 78 times we need to press. Next, coming to CB, here 1000 is given. So if you multiply 10 with 100, because 10 into 0 0 ones place, next 10 into 0 tens place also 0, next 100s plus 10 into 1 10. In other words, we get 1,000, that is 1000. So the answer is 100 times here. 100 times we need to press the plus 10 button. Next, coming to D bit, here 3700 is given. So similarly, if you multiply 10 with 370, then we get 3700. So that in other words 3700. So the answer is we have to press plus 10 button 370 times. Next 10,000 is mentioned. So if you multiply 10 with 1000, we get 10,000. So the answer is 1000 times. Next one is 1 lakh. So if you take 10 and if you multiply this one with 10,000 times, because 10 into 0 0 ones place, next 10 into 0 tens place also 0, next 10 into hundreds place also 0, that is 0, 10 into 1000 place also 0 0, 10 1 ja 10, that is 10,000 place digit is 1, so 10 1 ja 10. So here we have to put the commas after lakh place and thousand place. So then we displace 1 lakh. So the answer is 10,000 times we need to press this button. Finally here the last bit, that is G bit. So in order to uh, if you press this button 435 times, so 10 into 435. So what does it shows? Simply we have to place a 0 after 5. So that means 4350. It shows 4350. Next, coming to the third question, here you can observe third calculator. You can show here only it has a plus 100 button. Sorry, plus 100 button. So the handy hundreds only has a plus 100 button. How many times should it be pressed to show? So just like previous case, here we have to multiply with 100 here. So in order to show first bit 400, how many times we need to press? So 100 into 4, 100 4 is 400. So that's why here first answer is 4. Next, second one is 3700. So if you multiply 100 with 37, so the answer is 3700. In other words 3700. So here we have to press this button 37 times. Next, coming to sixth page of the textbook, here C bit is given, so 10,000. So in order to show 10,000, how many times we need to multiply 100? So 100 into 10, it will give 1000. So 100 into 100, it will give 10,000. So the answer is 100 times we need to press. Next 53,000 is given. So if you multiply plus 100 button 530 times, then we get 53,000. So answer is 530 times. Next, coming to 90,000, just like previous cases, here 100 into 900 if you take, the answer is 90,000. So here we have to press that button 900 times. Next, coming to bit F, 97,600 is mentioned. So 100 into 976 we have to take. So it generates 97600. So in other words 97,600. So the answer is 976 times. Next one is 1 lakh. So if you multiply plus 100 button 1000 times, then we get 1 lakh. So the answer is 1000 times. Next, H bit. Here if you press plus 100 button into 582 times. So what is the result that we have to write? So 582. So here two zeros we have to write after 2. So that means 58,200 is the answer. Next, coming to I bit, how many hundreds are required to make 10,000? So if you multiply 100 with, for example, 10, what is the result? 1000. If you multiply 100 with 100, then we get 10,000. Therefore, how many hundreds are required to make 10,000 means 100,000 is the answer. 100,000. Next, coming to J bit, how many hundreds are required to make 1 lakh? That means here we multiplied 100 button with 100 times, we get the 10,000. If you multiply 100 button with 1000 times, if you multiply or press that button 1000 times, then we get 1 lakh. So the answer is, how many hundreds are required means 1000 hundreds are required. Next, last bit in this third question, K bit, that is Handy 100 says there are some numbers which tedious tens and thoughtful thousands can't show, but I can. Is this statement true? Think and explore. So this statement is actually false for tens, because all multiples of 100 can also be multiples of tens. But here it mentioned that there are some numbers which tedious tens and thoughtful thousands can't show, but I can. So for example, if you take 500, so 10 into 50, 500. So 100 into 5 also 500. So that means that whatever the numbers shown by the 100 can also shown by the 10. Similarly, you can take one more example like 10 into 90 is 900. 100 into 9 also 900. But because it mentioned can't show, so this given statement is false. But the given statement is true, second one, for thousands case, because statement is true for thousands because some multiples of hundreds can't be multiples of thousands. Here it is true. Why? Because for example, if I take 100 into 2, what is the result? 200. So this is a multiple of 100, but by using thousands button we cannot show 200 because 1000 into 1 least value is 1000, that's why. Similarly, you can take one more case, for example 100 into 7 also 700. This is also can shown only by hundreds but cannot shown by the 1000. Coming to fourth question, creativity, you can observe this figure is a different kind of calculator. It has the following buttons: plus 1, plus 10, plus 100, plus 1000, plus 10,000, plus 1 lakh and plus 10 lakh. So all the different types of buttons are there in it. It always has multiple ways of doing things. How so? You might ask, to get the number 321, it presses plus 10 32 times and plus 1 once. Will it get 321? Alternatively, it can press plus 100 2 times and plus 10 12 times and plus 1 once. So here, to show the 321, so here to show this 321, they mentioned that plus 10 button has to be pressed 32 times. So 10 into 10 to the 20. So 0 in 1's place, 2 is in 10's place as a carry. Next 10 3 is 30 plus previous carry to 32. So we get here 320. Now it is also mentioned that plus 1 button, it has to be pressed only one time. So here 1 1 ja 1. So that's why I am placing it in ones place. So if you add these two numbers, 0 plus 1 1, 2 plus nothing 2, 3 plus nothing 3. So 321. So yes, it is correct and it will get. They also mentioned alternatively, we can also get 321 if it press 100 button twice or two times. So 100 2 is 200 here. Next plus 10 button if it press 12 times. So here 12 into 10 is 120. Next plus 1 button one time. So the answer is 1. So if you add 0 plus 0 plus 1 1, 0 plus 2 is 2 in tens place. Next in hundreds place 2 plus 1 is 3. So by pressing like this also, with this combination also, it will get the same result 321. So for this also, yes, it will get. Coming to fifth one, two of the many different ways to get 5072 are shown below. These two ways can be expressed as a bit 50 into 100 plus 7 into 10 plus 2 into 1 5072 5072. Another way is b bit 3 into 1000 plus 20 into 100 plus 72 into 1. If you multiply and add the results, we get 5072. So here find a different way to get 5072 and write an expression for the same. So other than these two combinations, we have to try for different combination. In two more ways, we have to show the same result by pressing different combinations of the buttons. So here I am taking one combination 4. If I multiply with 1000, 4 into 1000 plus 10 into 100 plus 7 into 10 plus 2 into 1. So 4 into 1000 is 4000 plus 10 into 100 is 1000 plus 7 10 ja 70 plus 2 1 ja 2. So if you add these 4000 with 1000 with 72, so final answer is 5072. So this is another way of representing the 5072. So next, figure it out. For each number given below, write expressions for at least two different ways to obtain the number through button clicks. So here, just like this figure, how to get the 5072 by pressing different combinations of the button. Here also for the given numbers, we have to at least represent in two different ways. So first one 8300. So to obtain the number through button clicks, think like Chitti and be creative. So here first one, if you take 8300, so first one I am taking like this 80 into 100 plus 30 into 10. So which gives 8000 plus 300. So that is 8300. So another way of representing this, another combination, if you press 1000 button 8 times, then 100 button 3 times, so 8 into 1000 is 8000 plus 3 into 100 is 300. So if you add them, you will get again 8300. So in the same way, coming to B bit, one way of representing is 4 into 10,000 plus 6 into 100 plus 2 into 10 plus 9 into 1. So which will give 40,629. So the other method is, if you press 1000 button 40 times, 40 into 1000, then if you press plus 10 button 62 times, so 62 into 10, and if you press play 1 button 9 times, 9 1 ja 9, so we will get 40,000 plus 620 plus 9, that is 40,629. Next C bit, it is given as 56,354. So first way of representing, I am taking like this: 56 into 1000. 1000 button we need to press 56 times, plus 10 button 35 times. So 35 into 10 plus 1 button 4 times. So 4 1 ja 4. So 56,000 plus 350 plus 4. It will give the required answer, that is 56,354. In other way also we can represent like this: 5 into 10,000 times. That means 10,000 button we have to press 5 times. Then 1000 button we have to press 6 times. Then 100 button we have to press 3 times. Finally 1 button we have to press 54 times. So like this also you may get here 50,000 plus 6,000 plus 300 plus 54. So if you add all these, we will get same answer, that is 56,354. Now its continuation is in page number 7, and that is D bit here. So 66,666 is given. So first method I am taking like this: 6 into 10,000 plus 6 into 1000 plus 6 into 100 plus 6 into 10 plus 6 into 1. So it will give you 60,000 plus 6 into 1000 is 6,000, 6 into 100 is 600, plus 6 into 10 60, plus 6 into 1 6. So if you add all these, we will get 66,666. Another way also there. Here I am taking second way like this: 66 into 1000. So 1000 button we have to press 66 times, plus 66 times we have to press 10 button. Next one time 6 times plus 1 button. So like this also we will get the same result. In this, the last number given a E bit 3,67,813. So first method I am taking like this: 1000 button 367 times we have to press. Then 81 into 10. That means 10 button 81 times. Next 3 into 1. So you will get the result like this: 367,813. And the other way is 36 into 10,000 I am taking, and 78 into 100, and 13 times we have to press one button. So like this also we get the same result. So in page number 7, so Creative Chitti has some questions for you based on this calculator once again. So in that ABT you have to make exactly 30 button presses. What is the largest 3-digit number you can make? What is the smallest 3-digit number you can make? So with the help of this calculator, here we have to press any button your wish, only 30 times we have to press. Altogether 30 times. So the final result should be largest 3-digit number as well as smallest 3-digit number. These two numbers we have to get. So what might be the combination? So here first we will try to calculate largest 3-digit number. So here first I will apply trial and error method. So if I try to press 100 with 9 times, so what is the result? 900. Because generally the largest 3-digit number we try to achieve 999 actually 999. This is the largest 3-digit number. We will try whether we get it or not. So 9 is the single largest digit. That's why I'm taking 9 here. 100 into 9, 9. So how many times we need to press here? 9 times. Next 10 button I am taking 9 times. 10 button. So I will get 90. So here also 9 times I have to press 10. So 9 plus 9 is 18. So 12 times are left out. Because total number of given times are 30. So altogether must be 30. Only 30 times we need to press the button. Next 1 into 12, because 12. One button if I press 12, so I will get 12. So if I add 0 plus 0 plus 2, 1 plus 2. Next 10s plus 0 plus 9 plus 1, 10. 0 is in tens place, 1 as a carry. In hundreds place, 1 plus 9, what I am getting? 10 I am getting. So that means this here what we are getting? 4-digit number we are getting, but actually we want only 3-digit number. So this combination is not possible. So what we have to do? We will keep the first line as it is. That means 100 into 9 we will write as it is only. 900 we get. So 9 times. Instead of here 9, I will take this time. I will reduce 1. That means 9 minus 1, 8. So 10 times 8 times we have to press the 10 button. So 10 8 is 80 we will get now. So here it is only now 8 times. Finally here one button if I press 13 times, I will get 13 because 9 plus 8 is 17. 17 plus 13 is how much? 30 times. Exactly it is matching. So number of button presses also matching. Now we will see 0 plus 0 plus 3, 1 plus 3, 0 plus 8 plus 1, 10's place it is 9, and hundreds plus 9 plus 0 plus 0, 9. So 993 is the largest 3-digit number we can achieve. We cannot get triple nine. That is not at all possible. So the highest digit is 993. In the same way, now we'll try to find out the smallest 3-digit number. So second case, smallest 3-digit number. So for that, first I am taking generally what is the smallest 3-digit number? 100. Actually 100. So we will try to get up to 100. But is it possible or not? That we will see. So for that, I am taking 10th button and pressing that in 9 times. So 10 9 how much? 90. So here 9 times are covered already. Next, remaining is how much? 30 minus 9, 21. So 21 times we will take one button only, because below 10 only one button is there in that calculator. So 90 plus 20 is how much? 2. 9 plus 2 is 11. 100, sorry, it is 21. So triple one we get 21 times. 21 one. So 111 we are getting. But is it very nearer to expected one? 100? No, it is not possible. So what we have to do, instead of 10 into 9, we have to take 10 into 8 only. So we will get 80. 10 80 80. So here the number of times are 8. So remaining are how much? 30 minus 8 is how much? 22. So we need to press here plus 1 button 22 times. 1 into 22 directly I am taking. So 80 plus 22 we get. So 0 plus 2 2, 8 plus 2 10, that is 102. So this is the nearest, it is very near to 100 rather than triple one. So this is the correct answer. So in this, one more bit is given. 997 can be made using 25 clicks. Can you make 997 with a different number of clicks? So first we will see 997 how we are getting with the 25 clicks. Then we will try for different combination. So first we will see here 997 using 25 clicks. So 100 into 9. So here we get 900. So 9 times. Next 10 plus 10 button, if you press 9 times we get 90. This is also 9 times. So 9 plus 9 till now 18. Next one button, if you press 7 times. 1 7 is 7. So we will get 997. So if you have 9 plus 9 18, 18 plus 7 how much? 25. So in this way the first given sentence is correct. 997 can be made using 25 clicks. Now can you make 997 with a different number of clicks? Is it possible? Yes, it is possible. So we will try different combination. So 100 into 7 I am taking. So that is 700. So how many times now? 7 times. Next I am taking 10 button. I am pressing it 25 times. So we will get 250. So here 25 times. So finally I am taking of one button 47 times. So 1 into 47, 47. So here 47 times. So we will get the same result here. 0 plus 0 plus 7 7. 1's place. Next 10's place. 5 plus 4 9. Next 100's plus 7 plus 2 9. Same result we get 997 only. But here number of clicks are different here. So 25 plus 7 is 32. So 32 plus 47. So 79 clicks it takes to get the same answer. Here one more question also asked, how can we get the numbers same 5072 and 8300 using as few button clicks as possible. So here we have to get 5072 with less than 23 button clicks. So for that purpose I am trying this combination. 1000 I am multiplying 5 times, then 10 7 times, then plus 1 button twice. So here we get to 5000 plus 7 70 plus 2. So 5072. So therefore number of clicks, if you observe here, how many number of clicks are there? So here 5. here 7, here 2. So 5 plus 7 is 12, 12 plus 2 is 14. So with 14 clicks only we can get, instead of 23 clicks, here with less number of clicks we can get the 5072 using that calculator. In the same way 8300, in genuine way, if you take like 8 into 1000 plus 3 into 100, we may get more number of clicks. So here 1000 into 8 plus 100 into 3, this is short way. You may get in different combinations, at that time you may get more number of clicks, but here with less number of clicks only we may get the solution. So here number of clicks are here 8 plus 3. So with only 11 clicks we can get the solution. So in figure it out, page number 7, first question, for the numbers in the previous exercise, find out how to get each number by making the smallest number of button clicks and write the expression. So in previous exercise, we will take the numbers and we will try to represent with a few clicks only, and we also will write the expression. So from previous exercise, I took these numbers. So first one is 3,600,000. So here I am pressing 1 lakh button 3 times, plus 100 button 6 times. So we will get the 3 lakh here plus 600. So the result you will get this one, 3 lakh 600. So here smallest number of button clicks are here 3 plus 6. That means with 9 clicks only we are getting. Now second one, B bit, 5 lakh 4,085 I am taking. So 1 lakh button, if you press 5 times, you will get 5 lakh here. Next 10,000 plus nothing is there, you can skip. And in 1000 plus 4 is there. So 1000 into 4. Next in tens place 8 is there. So 10 into 8. And in ones place 5 is there. So 1 into 5 I am taking. So finally we will get here 5 lakh plus 4000 plus 80 plus 5. So we will get the same result. Here number of clicks 5 plus 4 plus 8 plus 5. So 5 plus 5 10, 10 plus 8 18, 18 plus 4 22. So using 22 clicks we can get the answer. Next I am taking C bit from previous exercise, 27 lakh, that is 30,000. So here I am directly taking 10 lakh. I am multiplying 27 times. And I am taking here 10,000 button. I am multiplying with 3. So with this we will get the answer. Here number of clicks are 27 plus 3. That means 30. Next D bit, 70,53,138. So here also 10 lakh button you take and multiply with 7. So you will get the 7 lakh. Sorry, 70 lakh. So then 10,000 button I am taking. Multiply with 5, we will get 50,000 plus 1000 button into 3, you will get 3000 plus 100 button one time you press, plus tens button you press 3 times, plus 1 button 8 times. So you will get the same result here. And here our concentration is mainly on number of minimum button clicks. So 7 plus 5 plus 3 plus 1 plus 3 plus 8. So here 7 plus 3 10, 10 plus 15 plus 1 16 plus 3 19 plus 8 27. Next, in this second question, figure it out. Do you see any connection between each number and the corresponding smallest number of button clicks? So here I wrote the answer in sentence. Yes, each number indicates place value. To get the smallest number of clicks, go in descending order from the highest digit place value or weightage position. For example, 1,30,000 is here. So we have to take first 1 lakh. Then we have to go in descending order, means then 10,000 place, 1,000 place, hundreds place, like that we have to go. So that means definitely there is a connection between every number and its corresponding smallest number of button clicks. So as per the weightage position, if you go, then definitely number of clicks also reduces. Now in that third question asked, if you notice the expression for the least button clicks also give the Indian place value notation of the numbers, think about why this is so. So if you observe every case, whatever the example we have taken, according to the minimum number of button clicks, that is as per the Indian place value system only. Yes, as per the Indian place value notation, like starting from rightmost, ones place, tens place, hundreds place, thousand place, 10,000 place, lakh, 10 lakh, crore, 10 crore, 100 crore, like that. If you go system, the expression for the least button clicks are interlinked. So if you go, for example, always we have to select the highest weightage position. From there, if you start and go in the descending order, then number of button clicks also reduces. So first we have to try to cover the 10 lakh, then lakh, then 10,000, then 1,000. So in this order we have to go up to ones place. Definitely number of clicks also reduces, that is as per the Indian number system. So thank you for watching this video. Please subscribe and share this channel.